In the earlier classes I have discussed about the series combination of resistances. Today I will discuss about resistances in parallel combination. As I discussed the previous videos about series combination of resistances, uh, I told that the current in the series combinations are same in every resistances. Similarly, here the voltage across this resistances is same, but current is not same in this case. When a number of resistances connected in parallel combination, the current will not same for the every resistances. Okay, so this is the I1 current flows from the R1 resistance, I2 current flows from the R2 resistance, and I3 current flows from the R3 resistances. That is after that the voltage across these points are equal. That means the voltage is same for parallel combination. Okay, so how can I uh, determine or find the equivalent resistance for this case? Let I1, I2 and I3 be the currents through the resistances R1 and R2 and R3 respectively, because I current flows from the positive terminal of the battery uh, divided in a junction point, that is called junction point. It is divided into three parts, that is I1, I2 and I3, and that's why it says that let I1, I2 and I3 be the currents through the resistances R1, R2 and R3 respectively. Then the current in the main circuit must be I is equals to I1 plus I2 plus I3. That is the total current, that I is equals to I1 plus I2 plus I3 is clearly visible to you. Since all the resistance have been connected between the same 2 points A and B, same 2 points A and B, all the resistances connected in the same points between the same points A and B. It is clearly visible. Since all the resistances have been connected between the same points A and B, therefore potential drop V is the same across each of them, as I discussed earlier, and that the voltage is same for the each of them, across each of them. By Ohm's law, the current through the individual resistance will be I1 is equals to V by R1, I2 is equals to V by R2, I3 is equals to V by R3. Okay, how can I find the equivalent resistance? The equivalent resistance Rp. Assume the equivalent resistance is Rp. So I is equals to V by Rp. That is clearly uh, clear from this circuit. Okay, and I is equals to I1 plus I2 plus I3. Putting the values of I1, I2, I3 and I also, we will get the equivalent resistance. Okay, for parallel combination. So that is the formula for parallel combination. Formula for parallel combination. For two resistances, for two resistances which is connected in parallel combination, the equivalent resistance you can find in by this formula. Write here R1 into R2 R2 divided by R1 plus R2. That is the direct formula for two resistances connected in series combination. You can find the equivalent resistance. You can find the equivalent resistance from this formula for two resistances connected in parallel combination. R equivalent for parallel combination when two resistances are connected in parallel combination. That is a formula. Okay, you can find the equivalent resistance from this formula when two resistances are connected in parallel combination. Okay, right now we will discuss about this problem. A letter A consists of a uniform wear of resistance 1 ohm per centimeter. The sides of the sides of the letter are each 20 centimeter long, and the cross piece in the middle is 10 centimeter long. While the apex angle is 60 degree, find the resistance of the letter between the two ends of the legs. That means that is shape A. You can see here clearly. That is shape A. And this is 20 centimeter, that is 20 centimeter, and this is 10 centimeter. That means that is 10 centimeter, that is also 10 centimeter, that is 10 centimeter, that is 10 centimeter. Okay, so it says that the a letter A consists of uniform wear of resistance 1 ohm per centimeter. पर सेंटीमीटर में वन ओम है. That means that is 10 centimeter. That means R1 is 10 centimeter, R2 is 10 centimeter, R1 is 10 ohm, R2 is 10 ohm, R3 is 10 ohm, R4 is 10 ohm, and R5 is 10 ohm. It is clearly says in our question. Okay, so you can clearly seen, if I current flows here, that is a branch, that is a nodal point, or that is called junction. Here I1 flows here and I2 flows in this part. Thus I2 flows in between and I1 flows in this direction. So I1 plus I2, that means I current back to the negative terminal of the battery. Okay, that means I2 flows here and I2 flows here. That means that is the series combination. That means that is series combination. Okay, so 10 ohm plus 10 ohm is equals to 20 ohm. Is this 20 ohm is directly parallel to this 10 ohm. So 20 and 10, that means 20 by 3 ohm. The equivalent resistance of this part is 20 by 3 ohm. You can see here the 1 by 20 and 1 by 10, that is called as R2 and R3 in series. That is I2 current flows this R2 and R3. That means R2 and R3 is in series combination, and the R5 and the equivalent resistance of R2 and R3 is in parallel combination. That means B and D is r by 1 by r is equals to 1 by 20 plus 1 by 10 is equals to 3 by 20. That means r is equals to 20 by 3 ohm. So the equivalent resistance of this part is equals to 20 by 3 ohm. 20 by 3 ohm. This 20 by 3 ohm is in series combination with this R1 and R4. That means 10 plus 20 by 3 plus 10 is equals to 26.67 ohm is the right answer from this for this question. Okay, I think your your doubt, you have no doubt, any doubt from in this question. Okay, that is a shape of A. Okay, you have to see this lecture in 720p, otherwise you will it is not visible clearly. Okay, so this is the question of mixed combination. Okay, that's why I will design that question for this lecture. So today's lecture is enough, I think, because I have no time right now. You can also watch the previous videos and complete it at first. I will discuss about Joule heating effect of electric current after this video. Okay, so bye.